Hi students, in the last class we started about software effort estimation techniques and we completed one type of approach known as bottom-up estimation approach. Okay, let us move to the next approach. It is known as the top-down estimation. Top-down estimation. The top-down estimation is normally associated with parametric models or algorithmic models. It means that the effort is mainly related to some parameters, or the effort is based on the parameters or variables associated with the characteristics of the final system. The project effort is calculated based on some parameters or some features of the system. A parametric model will normally have one or more formula in the form effort is equal to system size into productivity rate. So here we can see an equation: effort is equal to system size into productivity rate. The project effort is mainly related into two different variables known as system size and productivity rate. The effort is related to two parameters, and that parameters are system size and productivity rate. It is the two characteristics of the final system, size of the system, also the productivity rate. By solving the equation, we can get the project effort. So we can use the algorithm to calculate the effort. So such model can be known as an algorithmic model. So the top-down approach is normally associated with algorithmic model, or it is normally associated with parameters, so it is known as parametric model. Okay. Suppose instead of the system size and productivity rate, if you have figures for the effort expended on past projects, suppose in work days or man days, and also the system size, you should be able to work out a productivity rate. It can be calculated as productivity rate is equal to effort divided by system size. In the above equation or in the above statement, we calculated the effort. Suppose we know the effort and system size and we want to calculate the productivity rate. For that, we can use the parameters effort and system size, and the productivity rate can be calculated. Okay. Also, a more sophisticated way of doing this would be by using a statistical technique. That statistical technique is least squares regression. Using the least squares regression, we can derive an equation based on the system size and effort. So an equation can be formed as effort is equal to a constant plus size into another constant. Since we are using two different constants, the first constant I have named it by suffix 1 and the second constant is named by suffix 2. So effort is equal to constant 1 plus system size into constant 2. The effort can be calculated based on the system size. Two constant values can be used. It is a statistical technique, a technique we are using in statistics known as regression technique. That method is least squares regression. By using least squares regression, we can derive an equation based on the parameter system size to calculate the effort. So, such parametric models or algorithmic models are mainly the top-down approach or top-down estimation technique. So here we are calculating the overall effort required based on some characteristics of or parameters of the system. That is about the top-down approach. Okay. Then we are moving to the next estimation approach or the estimation technique. It is known as expert judgment. Expert judgment. Judgment by an expert. Who is an expert? An expert is a person who is knowledgeable about either the application or the development system. So, this technique or this estimation is asking for an estimate of task effort from an expert. That means asking an estimate from one who is knowledgeable about either the application or the development environment. It can be mainly used to change an existing piece of software. Or suppose if we want to modify an existing system, how much effort is needed? How much effort should be applied to modify a software? So, an estimator would have to examine the existing system or the existing code and he judged the proportion of code affected and from that derive an estimate. So the expert examines the existing system and derives an estimation. Someone already familiar with the software would be in the best position to do this. That person is the expert. An expert judges the estimation. Okay. So expert judgment can be considered simply a matter of guessing. But research shows that experts use a combination of an informal analogy approach where similar projects from the past are identified, supplemented by bottom-up estimating. Our next estimation technique is estimation by analogy. So, in the expert judgment, the expert have to mix multiple estimation strategies. One type of strategy is estimation by analogy. He can combine an informal analogy approach as well as bottom-up estimation approach. Okay, so it can be used when an estimation of the modification of an existing code, or the expert would have to examine the existing code in order to judge the proportion of the code affected, and from that an estimation is derived. That is all about expert judgment. Okay. Then we are moving to the next estimation strategy. Next approach known as estimating by analogy. This is also called case-based reasoning. Case-based reasoning. Here I am showing two different cases. By reasoning these cases, an estimation is prepared. Two cases means a source case and a target case. The source case means already completed projects are the source case. The target case means the new project we are developing is the target case. Here the estimator identifies the completed projects or the source cases with similar characteristics to the new project, that is the target case. The effort recorded for the matching source case is then used as a base estimate for the target case. So here the estimator identifies the differences between the target case and the source case. The difference between the completed projects and the new project, and adjust the base estimate to produce an estimate for the new project. The new project is estimated by adjusting the base estimate. What is the base estimate? The effort recorded for the matching source case is used as the base estimate. It is known as estimating by analogy. Okay. This estimation by analogy can be a good approach where you have information about previous projects, then it will be a good approach. Also, a problem is identifying the similarities and differences between the source case and target case is a problem, because there may have a large number of past projects to analyze. then you have to analyze several source cases to form a base estimate. So it is a problem. There are different software tools existing to identify the source case that is nearest the target. Such softwares are using to find the distance between the cases. They measure the Euclidean distance between the source case and destination or the target case. And software tools. One such software tool is Angel software tool. It is used to find the similarities or the differences between or the nearest source case of a target case. So such software tools are also available. So estimating by analogy is a case-based reasoning based on the source case and target case. Okay, I think you understand the three type of another estimation techniques that we have discussed in this class. The top-down approach, also known as parametric or algorithmic model. Then second type of approach, it is expert judgment. And the third one, estimating by analogy or case-based reasoning. Okay.